Students, in this video we will discuss some expansions of some basic functions with the help of Maclaurin's series. Okay, so here first we are discussing the expansion of e raised to the power x. So for the Maclaurin's theorem, basically we will use the Maclaurin's theorem. If you remember, the expansion of Maclaurin's theorem was this. We have already discussed this. This was the Maclaurin's theorem. This was the Maclaurin's theorem, and this is the expansion. We have its two variants, Lagrange's form of remainder and Cauchy form of remainder. We have its two variants. When p is equals to 1, we have Maclaurin's theorem with Cauchy form of remainder. When p is equals to n, we have Maclaurin's theorem with Lagrange's form of remainder. So we will use these, okay, as per the need. So let's see. The first expansion is e raised to the power x. So what is the function? Function is e raised to the power x. Now we need different order derivatives. So first find out the first derivative of the function e raised to the power x. Second derivative of the function is e raised to the power x. And so nth derivative of the function is e raised to the x. Now taking the Lagrange's form of remainder. So this was the remainder term of Maclaurin's theorem with Lagrange's form of remainder. So Rn is given by x raised to the power n divided by factorial n, nth derivative at theta x. So here Fn at x, but here is theta x. So that's why we will have x raised to the power n divided by factorial n, and this will be nothing but, according to this, e raised to the power theta x, where theta is in between 0 and 1. Okay, now the expansion will be, so first we have to prove that, because this is the theorem, however we have to use the expansion. So now we have to show that the remainder basically tends to 0. We have to prove this. So to prove this, we will utilize the infinite series. We will use the concept of infinite series. So if you will see in this remainder term, if you will see in the remainder term, we are having this type of term, x raised to the power n divided by factorial n. Suppose this is denoted by an, capital An, nth term of the infinite series is an, x raised to the power n divided by factorial n. So an plus 1 will be x raised to the power n plus 1 divided by n plus 1 factorial. Now we are trying to apply ratio test. So take the ratio of these two. So an plus 1 divided by an will be x upon n plus 1. Now take the limit n tending to infinite. So an plus 1 divided by an will be limit n tending to infinite, x upon n plus 1. And since x is a real value and here n tending to infinite, so this will be 0. So this is less than 1, and hence we can say that limit n tending to infinite an will be 0. And since an will be 0, so this x raised to the power n divided by factorial n, when n tending to infinite, this will be 0. And so limit n tending to infinite Rn is nothing but limit n tending to infinite x raised to the power n divided by factorial n multiply by e raised to the power theta x. And this quantity is free from n. So now when you apply the limit, so this will be 0 multiplied by this quantity, so this will be 0. So conditions for Maclaurin's series being satisfied. Okay, so if you will see the conditions of Maclaurin series, then obviously रिमाइंडर शुड बी 0. जब रिमाइंडर 0 होगा तो मैक्लॉरिन्स थ्योरम जो है वो मैक्लॉरिन सीरीज में कन्वर्ट हो जाएगी. सो दिस इज द एसेंशियल कंडीशन टू गेट द सीरीज, दैट लिमिट आर एन शुड बी 0. ओके, सो नाउ दिस इज द मैक्लॉरिन सीरीज. एफ एफ एक्स इज इक्वल टू एफ नॉट प्लस एक्स एफ डैश 0 प्लस एक्स स्क्वायर बाय फैक्टोरियल 2 सेकंड ऑर्डर 0 प्लस एंड सो ऑन एक्स रेज टू द पावर एन डिवाइडेड बाय फैक्टोरियल एन nth डेरिवेटिव एट 0 एंड सो ऑन. दिस इज द सीरीज. ये सीरीज तभी आएगी जब तक रिमाइंडर 0 नहीं होगा. रिमाइंडर को 0 शो करना पड़ेगा. ओके, तो रिमाइंडर को आप 0 शो करें लिमिट को, तब आपकी सीरीज बनेगी. दिस इज द एसेंशियल कंडीशन. सो नाउ एफ ऑफ एक्स इज, व्हाट इज एफ नॉट? फंक्शन इज ई रेज टू द पावर एक्स. सो एक्स की वैल्यू 0 रखेंगे तो ई रेज टू द पावर 0 इज 1. एक्स एफ डैश 0 इज अगेन ई रेज टू द पावर 0, सो 1. सो एक्स स्क्वायर बाय फैक्टोरियल 2 एक्स रेज टू द power 3 by factorial 3 and so on. So this is the series of the function e raised to the power x. Okay. Now second expansion is sin x. So again sin x, f of x is sin x, differentiate this, so we get cos x. Again we can write down this as in terms of sin as sin x plus pi by 2. Now differentiate again second derivative of the function, which is nothing but derivative of sin x plus pi by 2, which is cos x plus pi by 2. So again convert this into sine, so sine x plus 2 pi by 2. So and so on. So nth derivative will be sine x plus n pi by 2. So f possesses derivatives of every order for every value of x. Again use the Lagrange's form of remainder. So Rn will be x raised to the power n divided by factorial n, nth derivative at theta x. So x raised to the power n divided by factorial n, and this quantity can be evaluated with the help of this nth order. So replace x by theta x. So theta x plus n pi by 2. Here theta is in between 0 and 1. Now we will utilize because here we are having the term sine, and we know that the magnitude of sine is in between 0 and 1. So just take the magnitude of the remainder. So this is the magnitude of x raised to the power n divided by factorial n, sine theta x plus n pi by 2. So this is less than equal to x raised to the power n divided by factorial n, and this quantity is tending to 0 as n tending to infinite. We have already proved this. We have already proved this. So that's why this is 0, and hence this quantity is tending to 0 as n tending to infinite. So by Maclaurin's series, so this implies Rn tends to 0 as n tending to infinite, and hence we can say that f of x is equal to f naught plus x f dash 0 plus x square by factorial 2 second order 0 plus x cube by factorial 3 third order at 0 and so on. Now what is f? Function is sin x. Function value at 0 will be sin 0, that means 0 plus x. F dash 0 means f dash 0 is nothing but put x is equal to 0 here. So sin 0 plus pi by 2, that means 1. So put it 1 here. Similarly second order derivative at 0 will be sin 0 plus 2 pi by 2. Sin pi is minus 1. So here first order derivative will be x plus x square by factorial 2, this value will be 0, x cube by factorial 3, third order derivative at 0 will be minus 1 and so on. So ultimately the series is sin x is equal to x minus x cube by factorial 3 plus x5 by factorial 5 and so on. So this is the series of sin x. Similarly cos x. Okay. So cos x is as it is same. Function is cos x. First differentiate this. So we get minus sin x. Again write sin x in terms of cos, so cos x plus pi by 2. Now second derivative, which is minus sin x plus pi by 2, again write this in terms of cos, so cos x plus 2 pi by 2. So in general formula is nth derivative at x is cos x plus n pi by 2. So f possesses derivatives of every order for every value of x. So Rn will be x raised to the power n divided by factorial n, nth derivative at theta x, where theta is in between 0 and 1. So now x raised to the power n divided by factorial n, and this is nothing but with the help of this we can find out the value of nth derivative at theta x. So this will be cos, here will be theta, this will be theta x, this will be theta x plus n pi by 2. Okay, now take the magnitude, so magnitude of this quantity, and we know that the magnitude of cos will be obviously less than equal to 1. So we will get x raised to the power n divided by factorial n, and this tends to 0 as n tending to infinite, and hence by Maclaurin's series f of x is equal to f naught plus x f dash 0 plus x square by factorial 2 second order at 0 plus x cube by factorial 3 third order at 0 and so on. Now put f of x is equal to cos x. So this is cos x, value of cos x at 0 will be 1 plus x, this value from here f dash at 0 will be cos 0 plus pi by 2 is 0 plus x square by factorial 2, second order at 0 will be cos 0 plus 2 pi by 2, so minus 1 and so on. So the series will be cos x is 1 minus x square by factorial 2 plus x4 by factorial 4 and so on. So this is the series. Okay, So this was the third expansion. Now the fourth expansion of log 1 plus x for the range when x is in between -1 and 1. For this range, expand this. So what is the function? Function is f of x is log 1 plus x. Now log 1 plus x is well defined when 1 plus x is greater than 0, क्योंकि log हमेशा पॉजिटिव वैल्यूज के लिए डिफाइन है. So log 1 plus x is greater than 0, so x should be greater than -1 होना चाहिए. Okay, now differentiate this, so we get 1 upon 1 plus x. Again differentiate this, so we get second order derivative is equal to -1 upon 1 plus x square. Again differentiate this, so third order derivative will be -1 into -2 divided by 1 plus x cube. And so this is -1 raised to the power 2 into 2. This is 1 into 2, 1 into 2. So 1 plus x raised to the power 3. Again differentiates, so fourth order derivative will be -1 minus 1 raised to the power 3. Here we get, this is factorial 2, so this will be factorial 3 divided by 1 plus x raised to the power 4. So general formula will be nth order derivative of the function is equal to -1 raised to the power n minus 1 factorial divided by 1 plus x raised to the power m. And this is valid when x is greater than -1 due to this condition. Okay, so this possesses derivatives of all order when x is greater than -1. So now we will use the concept of Lagrange's remainder. So this is the Lagrange's remainder. Rn is equals to x raised to the power n divided by factorial n, nth order derivative at theta x, where theta is in between 0 and. Put the value, so x raised to the power n divided by factorial n, and put the value here, replace x by theta x here. So -1 raised to the power n minus 1 factorial divided by 1 plus theta x raised to the power n. And when you combine these two terms, so we get -1 raised to the power n minus 1 divided by, here is n minus 1 factorial, here is factorial n, so there will be cancel out, so we get only n. And when you combine these two terms, so x upon 1 plus theta x raised to the power n, where theta is in between 0 and 1 and x is greater than -1. Now there are two cases, because we can divide this range into two parts, -1 to 0 and 0 to 1. So first we are discussing the range when x is in between 0 and 1. Okay, 0 to 1 के लिए. So x is in between 0 and 1, that means positive value. Theta is in between 0 and 1, again positive value. So when you find out this value, so what will be the range? So the value of x upon 1 plus theta x is in between 0 and 1. Because x is in between 0 and 1, theta is in between 0 and 1. So when you find out the range of this quantity, so 1 plus theta x is also a 1 plus theta x. This quantity is obviously greater than x. And hence when you take the ratio x upon 1 plus theta x, so this will be is in between 0 and 1. When you substitute it here and n tending to infinite, then you will see that x upon 1 plus theta x raised to the power n tends to 0 as n tending to infinite, क्योंकि ये क्वांटिटी 0 और 1 के बीच में है. ठीक, तो this quantity is tending to 0 as n tending to infinite. Also here we have 1 by n, so 1 by n is also tending to 0 as n tending to infinite. इसका मतलब जब हम रिमाइंडर में n tending to infinite लगाएंगे, this quantity tends to 0, this quantity tends to 0, so ultimately Rn tends to 0. So limit n tending to infinite, Rn will be -1 raised to the power n minus 1 upon n, x upon 1 plus theta x raised to the power n, this tends to 0. Okay, so remainder tends to 0. Now case 2, when x is in between -1 and 0. So if we apply Lagrange's form of remainder यहाँ, तब क्या होगा? Then this quantity x upon 1 plus theta x is not less than unity and we cannot draw any definite conclusion. So अगर हम इसमें Lagrange's form of remainder लगाते हैं तो हम उसमें कोई conclusion नहीं निकाल पाएंगे, because this quantity is not less than unity. So in this case we will apply the concept of Cauchy form of remainder. What is that? Rn is x raised to the power n divided by n minus 1 factorial, 1 minus theta raised to the power n minus 1 and nth order derivative at theta x. Substitute the values, so we get minus 1 raised to the power n minus 1 x raised to the power n divided by n minus 1 factorial 1 minus theta raised to the power n minus 1 n minus 1 factorial divided by 1 plus theta x raised to the power n. After simplification, we get minus 1 raised to the power n minus 1 x raised to the power n, and from here we take 1 plus theta x common, so 1 plus theta x, so and combine these two, so 1 minus theta upon 1 plus theta x raised to the power n minus 1. तो एक पावर यहाँ से हमने बाहर निकाल ली है. ओके, नाउ अब इनका वैल्यू देखते हैं. रेशो ये कहाँ है? थीटा इज इन बिटवीन 0 एंड 1, एक्स इज इन बिटवीन माइनस 1 एंड 0. तो इस क्वांटिटी में अगर मैं थीटा से मल्टीप्लाई करूंगा तो इनइक्वालिटी सेम रहेगी. ओके, सिमिलरली हियर यहां अगर मैं माइनस 1 से मल्टीप्लाई कराता हूं तो इनइक्वालिटी रिवर्स हो जाएगी. सो माइनस 1 इज लेस देन माइनस थीटा इज लेस देन 0. माइनस से मल्टीप्लाई किया. नाउ हियर वी हैव 1 माइनस थीटा, तो एडिंग 1, इसमें 1 को ऐड किया तो 0 इज लेस देन 1 माइनस थीटा इज लेस देन 1. ओके, सो वी हैव दिस. सिमिलरली when you multiply this theta here, क्योंकि theta is a positive quantity, so inequality will be same. So theta here आएगा minus theta, theta x, and here theta into 0 will be 0. Here we have 1 plus theta x, so just adding 1 here, so 1 minus theta is less than 1 plus theta x is less than obviously 1. Okay, now here 1 minus theta is in between 0 and 1, and 1 plus theta x is in between 1 minus theta is less than this. So we can say that 0 is less than 1 minus theta and 1 minus theta is less than 1 plus theta x. So when you combine these two, so we get 1 minus 0 is less than 1 minus theta is less than 1 plus theta x. When you divide this quantity here, so we get 0 is less than 1 minus theta divided by 1 plus theta x is less than 1. So this quantity is in between 0 and 1. Now taking the powers n minus 1, so this power is tending to 0 as n tending to infinite, क्योंकि ये क्वांटिटी 0 और 1 के बीच में है. जैसे जैसे पावर बढ़ेगी क्वांटिटी छोटी होती जाएगी तो 0 की तरफ टेंड करेगी. So this quantity tends to 0. Now here x raised to the power n, because x is in between minus 1 and 0, so again x raised to the power n tends to 0 as n tending to infinite. Okay, so this tends to 0, this quantity tends to 0. Now we will find out the sign of this value. 1 upon 1 plus theta x is less than obviously 1 minus magnitude of x. Okay, so this quantity, this Rn tends to 0 as n tending to infinite. So ultimately we can say that Rn tends to 0 as n tending to, obviously जब ये 0 की तरफ जाएगा, ये 0 की तरफ जाएगा तो पूरी क्वांटिटी 0 की तरफ जाएगी. So Rn tends to 0 as n tending to infinite. Then the case number 1 and case number 2, we are taking case number 1 and case number 2 implies that Rn tends to 0 as n tending to infinite when x is in between minus 1 and 1. So thus by Maclaurin series, log 1 plus x is f0 plus x f dash 0 plus x square by factorial 2, so second order derivative at 0, plus x cube by factorial 3, third order at 0, and so on. Substitute the values, so we get this series. Log 1 plus x is x minus x square by 2 plus x cube by 3, and so on. So this is the expansion of log 1 plus x. Okay, now we have last expansion. This is the last expansion of 1 plus x raised to the power m, where x is in between minus 1 and 1 and m is a real number. Real number may be integer, may be non-integer, so we will take both these cases. So f of x is 1 plus x raised to the power m, and now here we have case 1 when m is a positive integer. Okay, so when m is a positive integer, for example, if you will see, if we have a positive integer, then what will be the case? Case will be 1 plus x raised to the power m, for example fourth. This is a positive integer, so we can differentiate this into up to fourth order, because this is our f of x. First order derivative will be 4 1 plus x raised to the power 3. Second order derivative will be 4 into 3 1 plus x square. Third order derivative will be 4 into 3 into 2 1 plus x, and then last order derivative, fourth order derivative will be 4 into 3 into 2 into 1, and then fifth order derivative will be 0, and so nth order derivative will be 0. where n is greater than 4. Okay, but if in place of integer this will be a, for example, 4 by 3, then here we can differentiate this number of times, because first derivative will be 4 by 3, 4 by 3 minus 1. So this will be 4 by 3, 1 plus x raised to the power 1 by 3. Again you differentiate this, so 4 by 3 into 1 by 3, and then this will be 1 upon 3 minus 1. So and so on. So in this case we can differentiate this number of times. Okay, so we will, that's why we have taken both the cases, when m is a positive integer and when m is not a positive integer. Okay, so now when m is positive integer, so first order derivative will be m into 1 plus x raised to the power m minus 1. Second order derivative will be m into m minus 1, 1 plus x raised to the power m minus 2. And so mth order derivative will be m into m minus 1, m minus 2, 3 into 2 into 1, that means factorial m. And nth order derivative will be 0, where n is greater than m. Thus by Maclaurin's expansion, so we have only finite number of terms and rest are 0, so remainder will be 0, and hence f of x will be f0 plus x f dash 0 plus x square by factorial 2, second order at 0, and last term will be x raised to the power m divided by factorial m, mth order derivative at 0. Put the values, so we get this expansion. Okay, so this is the expansion. Now case number 2, let m not be a positive integer. Okay, so nth order derivative will be what? Just differentiate this, first derivative, second derivative, mth derivative. So nth derivative will be m into m minus 1, m minus 2, m minus n plus 1, 1 plus x raised to the power m minus n for all n belongs to n, and x is not equal to minus 1. Why? Because if x is minus 1 here, so this may be infinite. So to avoid that condition, we have taken x is not equals to minus 1, and here also x is not minus 1. Okay, so now then by Cauchy's form of reminder, if you apply Lagrange's form of reminder, then again you are not able to get any conclusion. So that's why Cauchy form of reminder is used. So Rn is x raised to the power n divided by n minus 1 factorial, 1 minus theta raised to the power n minus 1, nth order derivative at theta x, where theta is in between 0 and 1. Substitute this value with the help of this. So we get m into m minus 1, m minus n plus 1 divided by n minus 1 factorial, x raised to the power n, 1 minus theta raised to the power n minus 1, 1 plus theta x raised to the power m minus 1. So now we can simplify this as this. So this can be written as 1 minus theta divided by this quantity 1 plus theta x raised to the power n minus 1. तो हमने इसको इस क्वांटिटी से डिवाइड करके लिखा है. ओके, तो जब हमने n माइनस 1 पावर इधर ले ली, तो यहाँ पर जो बचेगा वो बचेगा 1 प्लस थीटा एक्स रेज टू द पावर m माइनस 1. इफ यू सिंप्लीफाई or do the calculation, so you will get the same result. Here this term, so this is m into m minus 1, m minus 1 plus 1 divided by n minus 1 factorial and then x raised to the power n. Now अब हमारे पास यहाँ क्या क्या quantities हैं x में. We have this quantity in terms of x and n, we have this quantity in terms of x and m, and this quantity. So one by one we will deal. So first we will find out the sign of this. Since magnitude of x is less than 1 as per the given condition, so hence this quantity will be 0 as n tending to infinite. तो ये 0 की तरफ tend हो जाएगी. Second is this quantity. So now here when theta is in between 0 and 1, x is in between minus 1 and 1. So we have already proved in previous expansion that 1 minus theta upon 1 plus theta is in between 0 and 1, and hence 1 minus theta upon 1 plus theta x raised to the power n minus 1 tends to 0 as n tending to infinite. Now the last case, when m minus 1 is greater than 0, then this 1 plus theta x is in between 0 and 2. क्योंकि theta x की maximum value, दोनों का प्रोडक्ट करेंगे तो मैक्सिमम वैल्यू जो प्रोडक्ट की आएगी वो 1 आएगी. 1 सबसे मैक्सिमम. सो यू कैन रिप्लेस दिस थीटा एक्स बाय 1. सो अल्टीमेटली दिस सम इज 2. So 1 plus theta x raised to the power m minus 1 is in between 0 and 2 raised to the power m minus 1. So this is a geometric series. Okay. So now when m minus 1 is less than 0. So here we have taken two cases, when m minus 1 is greater than 0 and when m minus 1 is less than 0. So when m minus 1 is less than 0, then theta x is greater than equal to minus magnitude of x, and hence 1 plus theta x, just adding this number 1 both sides, so we get 1 plus theta x is greater than equal to 1 minus magnitude of x. Now taking the powers, so 1 plus theta x raised to the power m minus 1 is greater than equal to 1 minus magnitude of x raised to the power m minus 1, which is nothing but a finite value. Okay, so basically you can replace this quantity by a finite value, and hence Rn tends to 0 as n tending to infinite due to this factor and due to this factor. So this quantity becomes 0, and hence we can expand this with the help of Maclaurin series. So 1 plus x raised to the power m will be 1 plus, this is the f0, this is first derivative at 0 multiplied by x, this quantity is x square by factorial 2 and second order derivative at 0, and so on. So this is the expansion. Okay, so this is all about the expansion of functions with the help of Maclaurin series. And now in the next video we will discuss about the applications of Taylor's theorem. Okay, and this was your last topic. This is your last topic, applications of Taylor's theorem. We will discuss three type of applications: in convex functions, in maxima and minima, and in indeterminate forms. So this is the last topic. Okay, thank you.